Hello everyone. How are you all? And how about your studies going on? All good? That's really great. That's really great of you all guys. Once again, a very warm welcome to your very own channel. Let's crack NEET UG in English. Guys, myself Sharada Alok, I have been teaching chemistry at Resonance from past 10 years. And today's topic is we are going to discuss some important questions of thermodynamics. I'm repeating. Today, we all are going to discuss some important questions of thermodynamics. Yes. This is the first lecture of thermodynamics. We are going to have many more lectures over thermodynamics. Okay, guys. So stay tuned. Come on. Yes, do share the link of the video to all your friends who are in class 11, yeah, guys, preparing for NEET 2021, 2022, and all those who are in class 11, 12, or dropper. Yes, guys, soon we are going to start the class. How you can get connected to us. Before we start the class, let me answer to you all to this question. Yes, is that clear, guys? Is that clear now? Now, guys, I just want to tell you all that first of all, go to Play Store. I'm repeating, go to Play Store, then download the Unacademy Learning app. Okay, guys, and then just click on to NEET UG. I'm repeating, then just click on to NEET UG. Okay, guys, you can chat with your educator, you can get engaged in discussion, you can ask all your doubts. I'm repeating, you can ask all your doubts to the educator. You can participate in the poll as well. Okay, guys, okay. Along with this, you'll be getting live classes. I'm repeating, you'll be getting live classes, guys, which in which you are going to be taught by the top educators. Yes, it is going to evaluate your preparation with our regular mock test and quizzes, and you are going to get a detailed analysis of your performance as well. Is that clear, guys? Is that clear? Come on. Now, one more thing, guys, one more thing. All our courses are structured very much in line with the exam syllabus. Okay, guys, looking all your target, which is definitely going to help you to best prepare for your target, because these are all designed by the top educators across the nation. So just by getting one subscription, you get access to all our live and recorded classes, courses, which you can watch from the comfort of any of your devices. Is that clear, guys? Now, this is another type of subscription, guys, another type of subscription which is definitely going to take your NEET UG preparation to the next level by the personal coach. Yes, guys, the top educators are going to be your personal coach. You're going to get a one-on-one guidance from top exam expert as your personal coach, and they are definitely going to, yes, help you to give a preparation strategy which is definitely going to ensure your every success in the target you are preparing for. Along with this, you'll be having an in-depth test analysis with personalized feedback, which is definitely going to improve your time management and exam approach. Not only that, you are going to get a study planner, proper study planner, which is definitely going to ace your preparation with customized study plan. You are going to get a bi-weekly review that is definitely going to highlight your progress. So all our live classes from top educator, mock tests and quizzes, structured batch course very much in line with the exam syllabus you will be getting just by taking this one iconic subscription, guys. Now you must be wondering, most of you who were not knowing it, whether to go for plus subscription or the iconic one. Let me tell you whether to go for plus subscription or the iconic one. Guys, whatever you are supposed to get under plus subscription, you'll be getting under iconic one as well. But as the name iconic is added to this, therefore it is going to have some iconic features, whether you talk about the top educators acting as your personal coach or proper study planner, expert guidelines, and in-depth test analysis. Yes, these are the additional features, iconic features you are going to get in addition to plus subscription. How much you have to pay for plus subscription, let me tell you, guys. For 6 months you are supposed to pay 38,000. For 12 months you'll have to pay 65,000. For 2 years you'll have to pay 1 lakh. Don't forget to apply this referral code of mine, SA10. You'll be getting Siddharth Chaudhary. Welcome back to the class. How are you, dear, and how about your studies? So guys, you'll be getting what? You will be getting the 6 month subscription only for yes 34,200 by applying this referral code of mine. 1 year subscription you'll be getting in just 58,500, which is going to cost you only 4,875 rupees. For 2 years you'll have to pay 90,000, guys, which is going to cost you only 3,750 rupees per month. Yes, guys, you heard me right. This iconic subscription for 2 years is going to cost you only 3,750 rupees per month. But don't forget to apply this referral code of mine, SA10. So, guys, this is all about plus subscription on the screen. You can see right from 1 month to 2 years subscription are there on the screen. Guys, for 1 month, you are supposed to pay 7,000. For 3 months, you'll have to pay 17,500. For 6 months, you are supposed to pay, yes, only 28,000. For 1 year, you'll have to pay 38,500. And for 2 years, you're supposed to pay 56,000 only. But once you apply this referral code of mine, you will have to pay only 6,300 for 1 month, 15,750 for 3 months, 25,200 for 6 months, 34,650 for 1 year, which is going to cost you only 2,888 rupees per month. 50,400, yes, 50,400 for 2 years, which is going to cost you 2,100. Guys, this is the referral code of mine, SA10. Don't forget to apply this referral code of mine. One more thing, guys, one more thing. Do share the link of the video of today's class to all your friends who are preparing for NEET 2021 2022. I mean, are in class 11, 12, or a dropper student. Share the link of the video to all of them. And all those who are watching this channel for the first time, in order to crack NEET UG, yes, whether you are appearing for NEET in 2021 or 2022, just if you want to crack NEET UG, just subscribe button. Just click the subscribe button for the channel Let's Crack NEET UG in English. And I just want to tell you, you can join us at our Telegram ID under the name Let's Crack NEET UG in English. Yes, guys, you can talk to all the educators over there. Yes, at our Telegram ID Let's Crack NEET UG in English. One more thing, guys. What is that? Do subscribe the channel and don't forget to press the bell icon too in order to have further notification. So what is there on the screen is talks about what? Thermodynamics. Yes, you are going to get exothermic, you are going to get endothermic reaction. Whether fire will be there or not, that is not necessary, but exothermic reaction has to be there. So we are going to study all this. Yes, guys, less random state. Yes, leave ice at room temperature. Ice is less random, whereas more random state when it is in water. Yes, is that clear, guys? Is that clear? Solids are less random, whereas liquid are more random than solid, and gaseous phase is much more random than liquid. We are going to have all these. Don't worry. Do share the link of the video, guys. All those who are watching, do like the video, do share the video, do subscribe the channel, do press the bell icon if you have not done so far. Now, guys, let us have a look at the very first question. Guys, delta U naught. What's that? Delta U is change in internal energy. If it is not, what does that mean? That not indicates what, guys? That is at standard condition. This delta U not is referring to the standard condition. Okay, guys. Okay. Of combustion of methane is minus x kilojoule per mole. What is the value of delta H? That is enthalpy. Okay, okay, guys. Internal energy of combustion of methane is given. What is the value of enthalpy of combustion? That is the question. Did you get the question, guys? All those who got the question, do reply in the chat box faster. And all those who are watching, please, 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 if you really want to get most out of the video, do participate, do answer in the chat box. Then only you will able to get most out of it. And all those who will watch this, yes, guys, like offline, do one thing, ensure that you are, before seeing the solution, just after reading the question, pause the video, try to solve it yourself, and then run the video and check your answer whether you have done it correctly or not. Download the video. Those who will watch this video like offline, then do one thing, download the video, keep read the question, keep reading the question properly, try to solve it yourself first, and then, guys, what you have to do, just just pause the video for a moment. After reading the question, try to solve it yourself and then check whether you have done it correctly or not. That is the best practice if you really want to get most out of this classes, whether video lecture, online classes, or if you watch the video lecture offline. That is the best way to get most out of the video lecture. Okay, simply having moonfully and chit chatting with friends and watching the video lecture is not going to help you a lot. Trust me. Trust me, guys. Okay, have a look at the screen now. Thus, delta U naught of combustion of methane is minus x kilojoule per mole. What is the value of delta H naught? I'm repeating. What is the value of delta H naught? Okay, guys, we know that enthalpy and internal energy are related to each other with this equation. Guys, H is equal to U plus PV, or P on differentiating. Yes, you get P delta V or V delta P. We all know that what? Yes, this come out to be the final equation, which is coming out to be, or the final formula which we are supposed to use over here is this: delta H is equal to delta U plus delta N gas RT. Where what is this delta NG? What's this delta NG? G for gas. What is this? This is actually the difference of gaseous moles. I'm repeating, gaseous moles of product minus gaseous moles of reactant. Is that clear? Gaseous, this is the difference of gaseous moles of product minus gaseous moles of reactant. Okay, okay, guys. So it is very, very clear from this equation. You can see in the inbox, guys. Delta H is equal to delta U plus P delta V for a reaction in which no gas is generated or consumed. Little expansion work is done in the difference between delta H and delta U is negligible. So we can see that this delta NGRT, because delta NG is going to be 0, so delta NGRT will always be 0. So you'll be getting the value in that case as delta H to be equal to delta U. Is that clear? Is that clear, guys? Now let us have a look. Guys, combustion of methane. What is the equation? How the equation can be written for combustion of methane? Methane, CH4. What is the state? Gaseous. On combustion, that is with reaction with oxygen. Is that clear? Clear, guys? Now, this is going to give you CO2 gas. Then, along with that, you'll be getting H2O. Yes, remember guys, for combustion, water vapor comes out in the form of liquid state. Always remember, don't ever do this mistake. Okay, so water is in which state? Liquid state. whenever you write down a combustion equation, do mention the water vapor coming out as or under liquid state. This is very, very important, guys. Water vapor, whenever you are writing down an equation for yes, thermodynamic equation, I mean combustion equation. Guys, combustion equation. Water vapor is always going to form in the liquid phase. I'm repeating, water vapor will come out in the form of dough. We call it as water vapor. But the water which is coming out after combustion, during combustion, is mentioned in liquid state because it is actually get liquefied over there. It's that. Is that clear? Clear, guys? Have a look at the screen. Now balance it. Guys, 4 hydrogen means this will be 2H2, 2 oxygen from water and 2 oxygen from here. So total 2 oxygen molecule will be required over here for this combustion. Is that clear? So methane is in gaseous state, oxygen is in gaseous state, CO2 is in gaseous state. So what is the value of delta Ng, gaseous moles of product? How much gaseous moles of product? Guys, only CO2 is in gaseous state, whereas H2O is in liquid state. Is that clear? H2O is in liquid state. All those who are watching, do like the video, do share the video. Okay, guys. So we will count only CO2, which is over here as 1. Okay, 1 mole of gaseous CO2. Guys, you need not to include the molecule of water. Remember, minus 1 mole of CH4 and 2 moles of oxygen. Both of them are gaseous. So 2 plus 1 is coming out to be 3. So subtract, because only gaseous moles of product. In order to calculate delta Ng, you will take only gaseous moles of product and subtract gaseous moles of reactant from that in order to find out the value of delta Ng. So it is going to be minus 2. I'm repeating. It is going to be minus 2. Is that clear? Now just put this value of delta Ng into this. Okay. Take the value delta H is equal to delta U plus delta Ng gas RT. Okay, done. Delta U is how much? It is minus X kilojoule. All done. It is minus X kilojoule per mole given in the question. Any doubt, guys? Any doubt? Come on. All those who are watching, do like the video. Yes, guys. Plus delta Ng is how much? Minus 2 RT. Guys, this is minus, this is minus. Is that clear? Is that clear? Therefore, what is the, make it delta H naught and delta U naught. This naught stands for standard condition. Okay, guys, is that clear? So it is very, very clear from here that because it is all coming out to be negative. So can we say that delta H naught is actually less than delta U naught? Okay, guys, it is less than delta U naught. I'm repeating, delta H naught is coming to be lesser than delta U naught from this value, because delta H naught is got what? It is minus X, then further minus 2 RT. All clear, guys? All clear? So delta H naught is less than delta U naught. Done. D is the correct answer. D is the correct answer. All clear, guys? All clear? All those who are watching, do like the video. And one more thing, guys. Just if you really want to get most out of the video, most out of the live classes, the best way to watch the live classes is to take a pen and copy in your hand. Secondly, all your eyes on the screen. Third, guys, what? Third, what? Third is, third is, yes, ensure yourself that you are not getting disturbed by anything around you. You are not getting disturbed by anything around you. All clear? All clear, guys? Now let us have a look at the next question. Come on, all those who are watching, if you really want to get most out of it, solve the question and do reply in the chat box. The question is there in front of you with the option. Okay, tell me the correct option, but solve it first. Guys, the question is the enthalpy of combustion of methane. I'm repeating, enthalpy of combustion of methane and graphite and dihydrogen at 298 Kelvin hour. This is enthalpy of combustion of methane. This is enthalpy of combustion of graphite. This is enthalpy of combustion of dihydrogen. What do you have to do? You have to find out the enthalpy of formation of methane. Always remember, guys, if you are talking about formation of any molecule, first of all, you should consider formation of 1 mole only. Is that clear? Standard enthalpy change of formation, we always talk about formation of 1 mole. And it is very clear from the formula of methane that in order to form 1 mole of methane, we need 1 mole of graphite and 2 moles of hydrogen. I'm repeating, yes, 1 mole of graphite and 2 moles of hydrogen. Rekha Sharma, first of all, 2 likes are for you. But think over your answer again. No worries. Think over your answer again. I'm going to solve it on the screen very soon. Okay, beta. एक बार अपना आंसर फिर से चेक कर लो. Okay. And by that time, all those who have not replied yet, who are watching the video but no not answering, please take a pen and copy in your hand. Do reply, guys. Okay, then only you will get most out of the video. And all those who are watching, do like the video. I'm repeating, do like the video, do share the video. Okay, Rekha beta, try the question again. By the time I'm solving it, I am solving it on the board. Is that clear, guys? Okay, Rekha. Okay, Arpita. Okay, well done. I won't disclose which is the correct answer. You keep answering in the chat box. Solve it, answer it in the chat box. At the end, you will come to know which is the correct answer. Okay, guys. Okay, have a look at the screen now. So guys, the required equation for enthalpy of formation is this. We have to bring 1 mole of carbon in the left hand side and 2 moles of hydrogen in left hand side and 1 mole of methane on the right hand side. Okay, guys, is that clear? But before that, let us write down the enthalpy of combustion of methane. Guys, enthalpy of combustion of methane will be written as, first of all, no doubt combustion of methane, so methane has to be there. Let it be equation 1. Methane, enthalpy of combustion of methane, 2O2 gas, yes, giving what? Giving what? 1 mole of CO2 gas plus 2 mole of water in liquid state. Is that clear? For this, delta H value is how much? Delta H is given as 890 minus 890.3 kilojoule per mole. Is that clear? 890.3 kilojoule per mole. Units are very important. Okay, guys. Now the second equation is enthalpy of combustion of graphite. Let it be solid. Let it be solid. Then O2 gas will give CO2 gas. For this, delta H value is how much? Delta H value is minus 393.5 kilojoule per mole. Is that clear? Now the third one is what, guys? Third one is combustion of dihydrogen. So it will be H2. Combustion will require how much oxygen? Only half mole of oxygen. We need to have a balanced equation. Okay, guys, this is going to form only water and that too in liquid state. For this delta, yes, enthalpy of combustion C, delta HC, given as how much? How much, guys? This value is given as minus 285.8 to 85.8 kilojoule per mole. Is that clear? Now we have to add this equation in such a way that we get 1 mole of carbon and 2 moles of hydrogen. Is that clear? 2 moles of hydrogen. Okay, guys. So our aim is to get this equation. And 2 moles of hydrogen will be obtained only when you multiply this equation 3 by 2. Yes, the entire equation will be multiplied by 2 first thing. Even the energy is going to be multiplied by 2. Is that clear? Yes, done. Done, guys. आ रही है बात समझ में? All done. Now, have a look at the screen. We need only 1 mole of carbon, so let it be. Let it be as it is. But we want this CH4 in which side? We want CH4 in right hand side. So we have to reverse the equation. If you reverse the equation, delta HC will get reversed and the value will be plus 890.3 kilojoule per mole. Is that clear, guys? And then add them all. Okay, guys. So equation 2, yes, equation 2 plus multiply equation 3 by 2, that is 2 into equation 3 minus equation 1. Is that clear? Is that clear? Equation 2 plus 2 into equation 3 minus equation 1. But why minus equation 1? Because equation 1 may methane has to come to right hand side. On doing all this, guys, on doing all this, you will be getting delta H. Delta H for the required equation for this equation. Is that clear? Is that clear, guys? Now delta H for the given equation will be how much? Equation 2 is how much? As it is, add, keep the delta value. I mean delta H value. It is minus 393.5. All done. Plus 2 into, yes, minus 285. This is also minus, right? Yeah. Yes, guys. Sorry. Yeah. Minus 285.8, all done. Then minus, again you have to minus this equation 1 now. So minus to minus of that will be plus, isn't it? 890.3. Done, guys. On adding the all the values coming out to be minus 74.8 kilojoule per mole. Remember, in this case all the units are in kilojoule per mole, but remember, whenever you are going to do such questions, ensure whether the unit is same or not. If it is not same, your first duty is to make the unit same. Otherwise, you are not going to get the correct answer. Okay, guys. Okay, is that clear? In thermodynamics, you have to be very particular. कहाँ पे plus करना है, कहाँ minus करना है, और क्या? Units are very important, because most of the time I have seen that student makes a mistake only this. Okay, most of the mistake are done by the student in this two criteria under thermodynamics only. Okay, guys. Okay, now guys, have a look at the next question. By that time, all those who are watching, if you have not liked the video so far, do like. If you have not shared the video, do so. If you have not subscribed the channel, do so. If you have not pressed the bell icon, do so. Okay, guys, have a look at the screen. A plus B plus gives C plus D. Plus Q means what? Energy. Energy is also coming out. Is found to have a positive entropy change. All done. Okay, one more thing. In the previous question, Arpita, the two lights are for you for correct, making the question, solving the questions correctly. Well done. And yes, Rekha, are you okay, beta? Did you get the correct answer? The reaction will be what the reaction will be. Although I'm waiting for your answer in the chat box. Come on, do reply. Guys, if it is plus Q means delta H is negative. Why? Because if heat is liberated in the product side, that means it is exothermic reaction. Clear hai? Clear hai? Done. Have a positive entropy. What does that mean? Delta H, delta S is positive. Is that clear? Delta S is positive. Now, guys, delta H gives Helmholtz equation. Delta G is equal to delta H minus T delta S. This is what gives Helmholtz reaction. I mean equation, not reaction. Sorry. equation. All clear, guys? All done? Now, delta G is equal to delta H minus T delta S. It is very clear that delta H should be negative, delta S should also given as positive. It is given in the question that entropy, delta S means what? Entropy. Change in entropy is positive and enthalpy is negative, because plus Q means what? The reaction is exothermic, energy is liberated. All those who are watching, do like the video. If you have not done so, do share the video if you have not done so. Simply, guys, delta H is what? Look at the equation, Gibbs Hammond equation. Delta H is what? Yes, this is negative and this is negative. Delta S is positive. All done. So this is positive. Okay, okay, guys. Now, guys, negative and negative together has to be what? Negative. Okay, okay, guys. Always remember delta G in order for a reaction to be spontaneous, delta G has to be negative. Delta G, if delta G is positive, that means it is non-spontaneous reaction. Always remember, delta G has to be negative. And delta G, if it is negative, means it is spontaneous reaction. And if it is positive, it is non-spontaneous reaction. So it is very, very clear from the screen that delta G is coming negative for exothermic reaction at any temperature, no matter whatever value of temperature you take. It is going to be, it is going to be what? Negative. That is the reaction will be possible at any temperature. The reaction will be possible at any temperature. Okay, okay, is that clear? Clear, guys? Done. Have a look at the next question. In a process, 701 joule of heat is absorbed by a system. Guys, this much heat is absorbed by a system and this much joule of work, 394 joule of work is done by the system. Guys, this is W, work done by the system, minus, here W is given as work is done by the system, Q is plus because it is absorbed by the system. Okay, okay, guys, all clear है? यहीं से दिमाग लगाना चालू करो. Now, what is the change in internal energy? Remember, guys, internal energy, heat, and work done are related to this equation. Okay, where delta U is difference in energy between reactant and product. Q is heat given or lost from the system. W is the work done by or on the system. All clear? This is how it is related. Let us solve this, guys. This is actually called as what? First law of thermodynamics. What's that? Flot. First law of thermodynamics. Okay, okay, guys. Now just you know the value, put the value over there in the equation simply, and you will be getting the answer. All clear, guys? All clear. Let us see what we have to calculate. We have to calculate internal energy. Okay, have a look at the screen. Delta U is equal to, guys, delta U is equal to Q, because Q heat is given to the system. So it will be plus 701. Okay. And work is done by the system. So work done will be negative. It is going to be minus 394. And remember, both of them are in joule. So we need not to worry because the units are same. But remember, always look for the unit. Okay. Okay, guys. Have a look at the screen. Subtract it. So after subtracting, the value comes out to be how much? Yes, it is 307 joule. All clear? Guys, if in the option it is kilojoule, that means it is 0.307 kilojoule. All clear? Can be taken as zero point 0.3 kilojoule. So look for which is the option given there. Click on that only, because I told you in thermodynamics most of the time unit mistakes are quite oftenly done. So be very careful for the units. Now, guys, the next question is the reaction of cyanamide with dioxygen. I'm repeating, the reaction of cyanamide with dioxygen was carried out in a bomb calorimeter. In a bomb calorimeter, and delta U was found to be this one at 298 Kelvin. Calculate the enthalpy change for the reaction. Very simple question, guys. Enthalpy change for the reaction where cyanamide is reacting or getting, yes, undergo combustion because it reacts with oxygen. It turns into nitrogen, it turns into CO2 and H2O. Guys, entire nitrogen during combustion is going to convert into nitrogen gas. Carbon, as usual, going to get converted into CO2. Water, as usual, I mean hydrogen, as usual, will get converted into water as it is shown on the screen. And the reaction is very well balanced. Okay, guys, let us see how this is to be solved. Come on, all those who are watching, do try solving this question. Take your copy and pen and write down the answer. Tell me the answer in the chat box. Faster, guys, faster. I'm waiting for your answer in the chat box. By the time, if you have not liked the video so far, do so. If you have not shared the video so far, do so, guys. Do so. Okay, guys. Okay. The required equation over here, formula is delta H is equal to delta U plus delta NGRT. I'm repeating. डेल्टा U को थोड़ा सा डेल्टा U की तरह बनाना है. Yes, delta H is equal to delta U plus delta NGRT. Clear hai? Clear hai, guys? Now, delta Ng is equal to gaseous moles of product minus gaseous moles of reactant. All done? Gaseous moles of product minus gaseous moles of reactant. Now, moles of product, 1 mole of nitrogen, 1 mole of CO2 only because this is in liquid state. Come on, be very particular about this. Whenever water is forming, H2O is forming in a combustion reaction, it is going to come out in the form of, you will always mention it in the form of liquid. Okay, okay, guys, clear? Now it is 2 minus. How much moles of gaseous reactant are there, guys? 3 by 2, that is 1.5 plus 1. How much it is? How much it is, guys? Yes, do let me know. One more thing, guys, there is a mistake. Cyanamide. Cyanamide is actually solid. It is mentioned in the question. Yes, even I was wondering how come cyanamide is gaseous. Okay, guys, this is there in the question also it is given. Cyanamide is in solid state. Therefore, only gaseous moles of oxygen are supposed to be considered. And that is 3 by 2 simply. How much it is? 2 minus 3 by 2 will be simply 1 by 2 mole or 0.5. Just put on the value over there in the equation. All clear? Clear here, guys? What we have to calculate? We have to calculate delta H. So put on the value of delta U. Guys, delta U was found to be minus 742.7 kilojoule per mole. So right here, minus 742.7 kilojoule per mole. Remember the unit, isn't it? Plus delta Ng, that is to be what? 1 by 2. Okay, guys, okay. And this R, which value of R is to be taken? R value, there are three values of R. One is in ATM, yes, ATM, liter per mole per Kelvin, the value is 0.0821. And when it is taken in joule, it is 8.314 joule per mole per Kelvin. But here guys, delta U is taken in kilojoule. I told you, be very particular about the unit. Therefore, R value will be written as 8.314 into 10 raised to the power minus 3 kilojoule per mole per Kelvin. All clear? Clear, guys? Now, what about the temperature? It is already given in Kelvin, so no problem. No need to convert it into Kelvin. Now, this is the product. All clear? Multiply them all, and the answer is here as 741.5 kilojoule per mole. Okay, guys, all clear? Clear? Come on. So nice of you. This is how, but this is very bad. I did not get any answer in the chat box. Do solve this and answer in the chat box. All clear, guys? Now let us have a look at this question on the screen. Okay, guys, all clear? Come on, all those who are watching, do reply, do solve this question and reply in the chat box. Okay, waiting for your answer in the chat box. This time, I want the answer, yes, by you all. Guys, the question is calculate the number of kilojoule of heat necessary to raise the temperature of 60 gram of aluminium from 35 to 50 degrees, 55 degree. That is, this is T1, this is T2. Okay, calculate the number of kilojoule of heat, that is Q. Okay, Q is being asked, T1 and T2 are given. Temperature of 60 gram, guys. So what is given over here? Mass is given over here. Molar heat capacity is given, guys. See, molar heat capacity. Take this. I hope the problem for the net is all sorted out now. Have a look at the screen. Yes, it's all done. It's all sorted out now. Okay, guys, have a look at the screen. Enthalpy of combustion of carbon. Guys, enthalpy of combustion, that is delta HC is given. Calculate the heat released upon the formation of CO2 from carbon and dioxygen gas. Very, very simple question. How come? Let us see. Enthalpy of combustion, guys, means what? Enthalpy of combustion of carbon means what? You write carbon as solid on reacting with oxygen. This is actually representing you the enthalpy of combustion to CO2. Yes, this is how enthalpy of combustion. This is the representation of enthalpy of combustion of carbon. All clear? All clear, guys? And this one is delta HC is equal to minus 393.5 kilojoule per mole. Guys, this is for 1 mole. Okay, what is being asked in the question? That this much is this is the enthalpy of combustion of carbon. Calculate the heat released upon formation of 35.2 gram of CO2. Very simple, guys. 1 mole of CO2 is forming in this, and during that this much energy is liberated. 1 mole of CO2 is how much? Atomic mass of carbon is 12, that of oxygen is 16. 2 into 16 will be 32. Together it is 44. Guys, 44 gram. I'm repeating, 44 gram of CO2. All your eyes on the screen now. 44 gram of CO2. All done? All done, guys. Is formed by releasing energy how much? 393.5 kilojoule, because 44 is actually 1 mole. Okay, so what we have to calculate? How much energy is liberating? Yes, during the formation of 35.2. Very simple. So guys, hence energy released in 35.2 grams CO2 combustion will be how much? Simply 393.5 upon 44 into 35.2 kilojoule. All done. This figure is somewhat 314.8 kilojoule. All clear, guys? आया समझ में? Very one of the most simple question, isn't it? But units, again units. Okay, let's go ahead for the next question, guys. Enthalpy of formation of CO is given, CO2 is given, N2 is given, N2O4 is given. Okay, guys, find out the value of heat of reaction. Guys, heat of reaction. Heat of reaction is to be found out. Remember, heat of reaction is always equal to sum of enthalpy of formation of the product minus sum of enthalpy of formation of the reactant. Okay, sum. Okay, guys, of enthalpy of products minus sum of enthalpy of, yes, reactant. Enthalpy of reactants. All clear, guys? Clear? Now, so what is to be done? Yes, molar enthalpy, you have to take the value, and the given values are, guys, products are N2O and 3 moles of CO2. So be very particular, have your eyes on the screen, and those who have not liked the video so far, do like the video. Do like the video and do share it. Guys, it will be heat of formation of N2O. Only 1 mole, so no need to multiply this further. Plus, because 3 moles of CO2, so 3 into, yes, heat of formation of CO2. All clear, guys? Clear? This will be 3 into molar heat of formation of CO2. All done. Minus what? Molar heat of formation of N2O4. Molar heat of formation of N2O4 plus 3 moles of Ca. It will be 3 into delta formation of CO. All clear, guys? All clear? आई बात समझ में? Now, this has to be molar heat of formation of N2O is how much? It is given as 81. So this will be simply 81 plus 3 into how much molar heat of formation of CO2 is given as? It is minus 393. So make it 3 into minus 393. All clear, guys? आ रही है बात समझ में? Then guys, minus heat of formation of N2O4. How much is that? 9.7 plus 3 into heat of formation of CO. How much is that? Minus 110. Yes, guys, solve it. Solve this, guys, and you will be getting the value as minus 777.7 kilojoule. All done. All done. You have to pause the video. Once you are watching the recorded video, pause the video and try to do the calculation yourself and then check your answer. All clear, guys? All clear? Let us go ahead now. Now the next question on the screen. Given N2 plus 3H2 is forming 2 moles of ammonia. Heat of the reaction is given. Very simple, guys. Heat of the reaction is given. What is the standard enthalpy of formation of ammonia? I told you that whenever we have to write down the enthalpy of formation of particular product, whenever you are supposed to write down the equation, always prepare 1 mole of that. In this case, 2 moles of ammonia is preparing. But in order to write down the standard, in order to calculate the standard enthalpy of formation of ammonia, only 1 mole of ammonia is supposed to be prepared. Always remember. 1 mole of ammonia will be prepared. For this, only half mole of nitrogen gas is required. Then, yes, how much mole of hydrogen is required? 3 by 2 moles. Only 3 atoms. Little explorer. Hello, beta. Welcome to the class. How are you, dear? How are you, little explorer? How much moles of hydrogen for this? Only guys, 3 atoms. That is only 1.5. 3 mole atoms, only 1.5. That is 3 by 2 mole of hydrogen. All those who are watching, do like the video. If you have not liked the video so far, do share the video so that many of your friends can also take benefit from it. Little explorer, beta, how about your studies? You're saying all fine. Do let me know whether have you studied thermodynamics or not. And all those who are watching, do reply in the chat box. Solve the question, do reply in the chat box. Okay, guys, so it is very clear from here that this particular equation is simply half of it, half of the equation given. And for this, the heat of reaction is this. So for this, the heat of reaction will be just half of that, that is minus 92.4 by 2. All clear? How much it will be? It will be simply minus 46.2 kilojoule per mole. Isn't it? Isn't it? Very simple question. Zaru, Bigda, the general tendency, still stuck on the MCQ of that chapter, ma'am? Well done. Then try to solve the question. Try to solve the question of thermodynamics, which we are going to do it or do on the screen. Do reply in the chat box. If you solve the question, do reply in the chat box, little explorer. If all those who are watching, if you really want to get most out of the live video, most out of the recorded video, the very best practice is to practice the question and answer. If it is the live class, answer the in the chat box. Okay, guys? Or if you're watching the recorded video, do one thing: pause the video, Just try to solve the question after watching the question properly, after reading the question properly. Solve the question properly. All done. All done, guys. After that, what do you have to do? Then check the answer. That is the best way. That is always the best way. All those who are watching the video, have not liked the video so far, do like the video. Okay, guys. And one more thing, thermodynamics, generally we have our perception that we are going to have very difficult question. It is not at all. As long as NEET is concerned, guys, as long as NEET is concerned, J mains are concerned, questions are going to be very, very basic type. Very, very basic type. Okay, okay. Is that clear? And let us go ahead. Now the next question, guys. Next question. Calculate the standard enthalpy of formation of methanol from the following data. I have already told you, guys. I have already told you. First of all, go for the go for the equation required for which the question is asked. Standard enthalpy of formation. We always take 1 mole of formation. Guys, 1 mole of formation of methanol. The equation can be written this way. CH3OH liquid hai, because liquid solid, they are very, very important. Remember, because the heat required for the conversion should also be taken care of. So here it is liquid. Simply write it as liquid. No problem. Okay, guys. So the required equation for this, how much mole of carbon is required? Can you tell me? Only 1 mole. Only 1 mole of carbon. So 1 mole of carbon. How much mole of hydrogen is required? 2 moles of hydrogen. Carbon is in solid. Write it solid. 2 moles of hydrogen. Write it gas. So 2 moles of hydrogen. And only half mole of oxygen. So make it half of O2 gas. So this is the required equation. Very, very simple, guys. This is the required equation. Try to add this equation, all the three equation, in such a way so that you get this equation, and try to add their delta H value as well. You will get the delta H value for this reaction. Is that clear? Clear. This will also be automatically, just by simple addition, subtraction, you're going to get the value of heat of formation. All clear, guys? Now, guys, it is very, very clear from here. We want 1 mole of carbon. That is there. So this is equation 2. Take equation 2 as it is. Okay, this is equation 2, this is equation 1, this one is equation 3, and we need 2 moles of hydrogen. So multiply equation 3 by 2. All simple, guys. And then you want this methanol to be on the right hand side, product side. Therefore, just reverse this, that is subtract this. On subtracting this, guys, on reversing this, delta H value will also get reversed. It will become plus 726 kilojoule per mole. It will become plus 726 kilojoule per mole. All clear? All clear, guys. Let us solve this now. Let us solve this now. So, guys, take equation 2, all as it is, done. To that, add 2 times of equation 3, done. Then subtract equation 1. All clear, guys? All clear? You're going to get the equation, because everything else is going to get cancelled. Oxygen, extra oxygen will get cancelled, CO2 will get cancelled. Okay, water vapor will get cancelled. You'll be getting only this one. All clear? All clear, guys? Now similarly, just subtract and add delta H value in the same manner. Guys, for this equation 2, delta H is how much? Minus 393 plus 2 into delta H of equation 3. Equation 3, delta H is minus 286. Make it 2 into minus 286. All clear? Then minus of equation 1. Equation 1, delta H is minus 726. So minus 726 has to be minus into minus. I told you it will become plus. All clear, guys? All clear? Just solve it further. You are going to get the value as, just a sec, the value will come out to be how much? 239. The value will be 239 kilojoule per mole. All clear, guys? All clear? All those who are watching, if you have not liked the video so far, do like the video, and come on, guys, do share it. And all those who are watching, do participate. Do participate by solving the question and answer in the chat box. All those who are watching have not liked the video so far, do so. Please like the video. Please share the video. Okay, guys. Have a look at the screen now. Now, guys, the next question on the screen. Very, very, yes, easy question. In fact, the similar one of the previous, isn't it? Nilesh Patel's sir. Hello, beta. Hello. Yes. How are you, dear? How about your studies? Do let me know in the chat box. Okay, guys. So nice to see you all, guys. See you all. Really, it's really wonderful to see you all, guys. Come on. Solve the question. Solve the question, guys, on the screen and reply in the chat box. Calculate the enthalpy change for the process. Guys, for this, the required reaction is this one. We have to calculate the enthalpy change. All clear, and determine the value of bond enthalpy for CCl in carbon tetrachloride. Okay, guys. Okay, is that clear? All the data required are given over here. What we have to do, we have to simply apply the data, and simple plus minus, you will get the answer. All clear, guys? Let us see how. Guys, the first equation is CCl4. Yes, heat of vaporization. That is from liquid to vapor. Let me write down the equation. CCl4 is in liquid state to CCl4 in vapor state. Done? Done, guys. Now this will be for this delta H value is 30.5 kilojoule per mole. All clear, guys? All clear now. That is the meaning of delta, that is heat of vaporization for 1 mole from CCl4 to CCl4 liquid to CCl4 vapor. Is that clear? Now the second one is heat of formation of CCl4. Okay, simply write down the equation for heat of formation. Always remember, for heat of formation, we always take it as, yes, we always take it the most stable state. CCl4 is found in liquid state. Okay, guys, so it will be liquid, and always we mention for 1 mole. Okay, okay. Now this will be C solid plus 2Cl2 gas. All done. For this, guys, delta H value is how much? It is minus 135.5 kilojoule per mole. All clear, guys? Now the second one is heat of combustion. Guys, heat of combustion is represented by the equation O2 gas will give you CO2 gas. Is that clear? Clear, guys? If it is heat of combustion, remember, heat of combustion is 715. All clear, guys? All clear? Now this is actually A, not heat of combustion. Soumya Anbu Sazian, ma'am, can you please tell why in our channel no physics mentor? Beta, in our channel Let's Crack NEET UG, if you download the Unacademy learning app, you will get physics mentor is there. Physics mentor is there. All clear? All clear, बेटा. पढ़ने से मतलब है चाहे YouTube पे पढ़ो चाहे Unacademy पे पढ़ो. Is that clear, Soumya? Have a look at the screen, beta. Have a look at the screen. Very soon, actually, we are going to have a physics mentor. Don't worry. Have a look at the screen now. Guys, this is what? Atomization of carbon. Atomization of carbon, because carbon is found in solid state. That is in Hindi. Okay, that is in Hindi. Very soon you'll get an English mentor too. Just wait. Just wait for a few more days. Very soon you are going to get a physics English mentor. English physics mentor. Don't worry. Is that clear? All those who are watching, if you have not liked the video so far, do like the video, beta. Do like the video. Okay, beta. Soumya, your problem. I will connect. I will talk to an academy and I will send your problem over there. Don't worry for that, beta. Okay, all done, Soumya. All those who are watching, do like the video. Do share the video. So, guys, carbon is in, yes, solid state. It has to be converted into gaseous or vapor phase, not gaseous, it is actually called as vapor phase. For this, the atomization, enthalpy of atomization is given Delta H atomization is given, guys, given as 715 kilojoule per mole. All clear, guys? All those who are watching, do like the video. Now, guys, the next one. Next one is what? It is given as enthalpy of atomization, that is dissociation energy of Cl2 molecule. It is given as 242 kilojoule per mole. So mention it there. Cl2 gas will give you 2Cl. Yes, 2Cl gaseous atom. Is that clear? Is that clear? This will be 2Cl gaseous one. For this, the enthalpy of atomization is 242 kilojoule per mole. Guys, it is very, very simple from here that all the energies are given in kilojoule per mole. Okay, okay, guys, is that clear? So, what you have to do, guys, this is equation 1, equation 2, equation 3, and this one is equation 4. So what we have to do, we have to get CCl4 in vapor phase in left hand side. In left hand side, that is, this reaction has to be reversed. Okay, okay, guys. Then guys, we want 4Cl. This is talking about formation of only 2Cl. So this equation has to be multiplied by 2. Okay, and then simply subtract equation. Yes, other equation, that is 1 and 2. That is what you have to do here. Let me write down this one. What you have to do here, guys, simply take equation 3. All done. Then 2 into equation 4. Is that clear? आ रही है बात समझ में? आ रही है बात समझ में? 2 into equation 4. क्यों किया? Because we want 4 chlorine. Isn't it? Isn't it, guys? Okay, okay. Now, minus equation 1 minus equation 2. Okay. सब कुछ सबकी सारे डेल्टा एच की वैल्यू डाल दो. इक्वेशन 3 का, देन 2 into इक्वेशन 4 का डेल्टा एच, देन माइनस इक्वेशन 1 का डेल्टा एच, देन माइनस इक्वेशन 2 का डेल्टा एच. ऑल क्लियर? इसको जब आप सॉल्व करोगे, यू विल गेट डेल्टा एच वैल्यू टू बी इक्वल टू 1304 किलो जूल पर मोल. यूनिट का तो टेंशन ही नहीं है. There is no tension of unit. So what is to be done here? What is to be done here? 1304 kilojoule per mole hai. What we have to calculate? This is actually for the 4 bonds over here. We have to calculate for 1 bond. So bond enthalpy for 1 CCl bond has to be this value divided by 4. All clear? 1304 divided by 4. Is that clear, guys? 1304 divided by 4. This will come out to be 326 kilojoule. 326 kilojoule per mole. All clear? Clear hai? Clear hai? Then do like the video. Do share the video, guys. Okay, okay, guys. Let's have a look at another question. Guys, once again, we got a very, very simple question. 2a plus b is giving you 2d. Okay, okay, guys. Delta U naught is given as minus 10.5 kilojoule. Delta S naught is given as minus 44.1 joule per Kelvin. Be very particular about the unit. I have been telling you since beginning, be very particular about the unit. All those who are watching, do like the video if you have not done so. Do share the video if you have not done so. Do subscribe the channel Let's Crack NEET UG in English if you have not done so. Do press the bell icon if you have not done so. Have a look at the screen now. So what do we have to do? We have to calculate the value of delta G naught for the given reaction, and we have to predict whether the particular reaction can occur spontaneously or not. It is very simple. Guys, if delta G value is negative, it will be spontaneous. All done. If delta G is going to come as positive, it will be non-spontaneous. So let us calculate the value, guys. Okay, delta U is given, delta S is given. Is anything else given? No. Let us see how it is to be given. Yes, something has been given which you have to find out. What is the value of delta Ng? Guys, 2 moles of gaseous product and 3 moles of gaseous reactant. So the value of delta Ng has to be 2 minus 3. I'm repeating, it has to be 2 minus 3, that will come out as minus 1. All clear, guys? We got the value of delta Ng. Delta U is already given. Already given. Okay, guys? Okay, okay. Then what else is given, guys? Yes, delta U is given. Delta standard condition temperature is also given, because not means what? Not means standard. Standard condition में temperature कितना होता है? 25 degrees centigrade. So we have to take the temperature as 298 Kelvin. दिमाग की बत्ती जलानी पड़ेगी. Yes, guys, दिमाग की बत्ती जलानी पड़ेगी. Though the question seems to be very, very easy, but by simple mistake in unit or by simple data mistake, you will lose the marks. So be very careful. Be very, very careful, guys. Okay, so temperature is there, R value, you know, delta Ng, you know, so put all the value here and find out the value of delta H naught. Make it delta H naught here. Standard condition. Okay, guys, standard condition. Clear hai, guys? Come on. Put the value of, yes, what? Delta U here, delta Ng here, R here, temperature here, and find out the value of delta H naught. Guys, delta H naught is coming to be equal to minus 12.98 kilojoule. I'm repeating, it is coming out to be how much? 12.98 kilojoule. Very, very simple, guys. Now, guys, this value is coming as kilojoule because delta U was taken in kilojoule. Be very particular about the units. Now, put this value of delta H into this Gibbs-Helmholtz equation. Delta S is in joule, delta H is in kilojoule. Be very particular, guys. So putting the value there, we get this delta G naught is equal to delta H, which is minus 12.98 minus T that is 298 multiplied by minus 44.1 divided by 1000. Then only it will come out in kilojoule. Is that clear? This will be in kilojoule per Kelvin. All clear, guys? All clear? Now solve this. The value is coming out to be 0.16 kilojoule, because as you have converted and this entropy value in kilojoule, so delta G naught has to be come out in kilojoule, which is what? Which is delta G naught is a positive value. As it is positive, it has to be what? It will not occur spontaneously. It is a non-spontaneous reaction. All clear, guys? Clear hai? समझ में आ रहा है? Then if you have not liked the video so far, do like, do share. Now let us go ahead for another question, guys. The equilibrium constant for a reaction is 10. What is that? Value of K. K is 10, guys. What will be the value of delta G naught? Very simple question. R is given, temperature is given, formula is known. Guys, delta G naught is equal to minus RT ln K, or taking the value of ln E, it becomes 2.3 minus 2.303 RT log to the base 10 K. Very simple, guys. Minus 2.303, R की value 8.314, temperature is 300, log to the base 10, and this is 1. Guys, this will be simply how much? The product of the three, which is coming out to be 5 minus 5744.1 joule. Very simple question of its type, isn't it? Very, very simple question of its type. Have a look at the screen now. Now, guys, now the next question, delta S is what? Entropy is equal to Q by T. Heat given or evaporated from the system. Yes, by temperature. So calculate the entropy change in surroundings. Guys, this is what? Surroundings. So you'll have to take Q surrounding. When 1 mole of water is formed under standard condition. Okay, guys. Yes, what is given here? Heat of formation is given here, which is minus 286 kilojoule per mole. So height is to be written, guys, H2 in gaseous state plus half O2 in gaseous state will form H2O liquid. All clear, guys? H2O liquid. The heat of formation given is how much? It is minus 286 kilojoule per mole. All clear, guys? समझ में आ रही है? Well done. Well done, guys. Now, guys, it is very, very clear. This means that when 1 mole of water is formed, this much amount of energy is liberated. All clear? 1 mole of water is formed means 286 kilojoule energy is released. It is this clear? Clear hai? Done. Done, guys. Heat is absorbed by the surrounding. This much energy is released. Water bana, release hui energy. Where that energy has gone? That energy has gone to the surrounding. Or another way, it is absorbed by the surrounding. It is absorbed. This is the system. वाटर बना एनर्जी रिलीज हुई इसके चारों तरफ क्या है सराउंडिंग है दैट रिलीज एनर्जी इज एब्सॉर्ब बाय द सराउंडिंग all clear guys so delta S is simply equal to q surrounding upon temperature clear guys simply 286 that is heat given to the surrounding or heat absorbed by the surrounding. Okay, 286 upon temperature. Standard condition, temperature, no need to be mentioned. How much just now I told you? 25 plus 273, 20, yes, 298 Kelvin. All clear, guys. This value is coming around 95, yes, 97. What? Unit, guys. Delta H formation is given in kilojoule per mole. So this also has to be in kilojoule per mole. What? Yes, not per mole. It will be simply kilojoule upon Kelvin. With the formula, you can make out the unit. So it will be simply kilojoule per Kelvin per mole. Because heat hai. Okay, all clear guys. In this case, per mole because we have to calculate for 1 mole. All done. Kilojoule or if it is given in joule, it will simply 959.7 joule per Kelvin per mole. All done guys. Did you understand this? All those who are watching, do like the video, then do share the video. And thank you guys for watching. If you have not liked the video so far, do so. And all those who have not subscribed the channel, let's crack NEET UG in English. Do subscribe the channel, do press the bell icon, do apply the referral code of mine SA10 in order to get 10% discount. Thank you guys. Thank you for watching. Thank you for watching, guys. Bye bye for now.